Hello, everyone, and welcome to our talk on a comparative study of typing and speech for map metadata creation. Let me start with the motivation. Why do we want to create metadata for web maps? Some may have come across this trend. There is an increasing number of online interactive maps that is available, and it is becoming increasingly cumbersome also to find them manually. There are emerging solutions trying to cope with the problem, mostly ad hoc. There are few data smart city solution, for example, try to list a visualization around a theme on a web page. Data USA is more a platform, a catalog like site where a lot of visualization can be found. There is a website by the Technical University of Munich listing online maps on Corona COVID. The Vis Gallery by Tableau. And in some cases, some of the maps are embedded in story maps, like in the case of MapX or ArcGIS story maps. So we are getting to the point where finding automated way to seek for maps is becoming increasingly needed, and that's why we try to look into metadata to facilitate the search of these maps. Another question is why speech? And the short answer here is because it's promising and speech recognition technologies have evolved quite well in the last years. Back in 2005, there was these authors, Sano et al. They were already using speech recognition to create metadata information for live TV broadcasting programs. And they reported back then already recognition rates of 82%. So speech is promising, and it has also been recognized in GI science. Leafia et al. At COSIT were calling for for more work to facilitate the discovery and reuse of open geospatial data via voice assistant. And I last year was arguing already for using speech to facilitate the cumbersome task of filling in form on mobile devices. So the argument is also applicable to desktop devices at large. Since there has been few work at empirically assessing the merits of speech, our idea in this empirical study was to look at it closely. Before I come to the prototype, I want to say a few words on related work, and one of the important work that has inspired us is the work on annotation of visualization. Back in 2009, here and colleagues have deployed a prototype called Sense.us, and what they reported from that prototype was that people, when given the opportunity, produce detailed annotation of maps. This is what you can see here with the arrows, where people have kind of annotated this visualization. Another study is that on the right-hand side, where the author was studying collaborative visual analysis, and reported that note-taking is a key activity in visual analysis or collaborative visual analysis. So basically what these things tell us is that we need means to support the recording of things that people learn when they are interacting with visualization online. I have proposed a design pattern to address that question and quickly go through it. What the design pattern helps to do is to record to document graphical notes, textual descriptions, and then turn them into machine readable description. It supports various types of graphical items that we find commonly in geovisualization: a map, of course, a chart, that data table, and it is also useful to document insight at various levels of granularity. And the prototype that we have built mostly reuse several elements of this design pattern. So before we come to the prototype, we wanted to see where we stand as far as GI metadata tools are concerned. So we surveyed on the Federal Geographic Data Committee wiki that provides lists of GI metadata tools. And we went also to the website of the Open Source Geospatial Foundation. We collected 25 tools, and the remaining 10 that are listed here are those ones that were working at the moment of the study. We quickly coded them along a few dimensions, and what we can see here is that typing is still the only modality basically that is supported in those tools, which is something that we expected, but that confirmed our guess at the beginning of this work. And another thing is that basically data set are the only resources that are annotated or where tools are produced to for the annotation, which is quite surprising because we have other items that we could use as search unit in GI science. For example, a sensor or a map, as we are arguing in this work. So we built a prototype, and the prototype supports annotation at two different levels, at the general level and at the specific level. At the general level, we support contextual metadata creation, for example, the addition of place name, an alternative place name, a topic, or a description. And at a more specific level, we support the addition of content metadata. So we built a number of tools. So we can use rectangle, we can use circle, or a pin, or a pencil to highlight a specific portion of maps where interesting patterns appear. And then we have seven different patterns: correlation, frequency, trend, outlier, cluster, distribution. And observation is the most generic pattern when none of the first 6 is applicable. And then, yeah, the recording of the pattern can happen either via typing or via speech recognition fully. At the end, the data that the annotation that the user produce is stored in a JSON LD format, and we use schema.org as vocabulary because schema.org is supported by major search engines, Yahoo, Google, Yandex, and our idea was that at the end of an annotation, people interested copy paste this and integrate it in the HTML document that is that is producing the website, or serving as frame to produce an online web map. And yes, so I won't go through the whole thing, but the main thing is that spatial temporal coverages are supported at the moment, and then the description, so space-time theme, is covered. The prototype is available online for extension and for testing, and we have also provided a data model which maps the user interface feature to the schema.org vocabulary. We have developed this data model in such a way that it can be reusable across scenario, and people could take this as a baseline to extend for their own work. Now coming to the user study, we did it online because it was between December and February of this year, the participant consent was recorded by video, since we couldn't have signature analog way. And then they went through tasks, so annotation with at the general level, contextual metadata creation, and then annotation at this specific level, content metadata creation. We counterbalance the order of the task to avoid any learning effect. And then we assess the user experience of the participant use in each of the conditions using a short version of the user experience questionnaire. At the end, we ask participants in a short interview to give us a reason why the ratings were provided as they did. 12 participants took place in the study. 2 of them were native speakers. We had a mix of interactive maps, mostly for contextual metadata creation, and static maps for content-based metadata creation. We use maps of 2 different themes that we changed so that participants won't get bored during the study. And then I produce at the end about 500 annotations. Since we use a web speech API, we provide a confidence score, which was 0.6 for further comparison in other studies. Coming out to the results, as far as efficiency, time on task completion is concerned, the type was a bit faster in contextual metadata creation when the input field were a bit smaller. But as we were demanding a bit more in the content descriptions, speech was faster, which is quite expected, but none of these differences were significant. And effectiveness, the self-correction of the participant during the tasks. In general, speech led to more error, and participants had to self-correct themselves, especially in the modality, in the content creation condition. A typical example was that there were several misunderstandings, if we may call them so, that way, and participants had to repeat the operation several times. An example was one participant said wildfire, and the speech recognition system understood why do fire. And at the end, in the interview, some of the participants said that they would have preferred using speech-to-text translation in their own language than in English. And this is an issue that we could look into future work. What is actually the actual impact of being a native speaker on the performance of the users? Then difficulty rating, or rather now easiness rating, as we show them here in general, the typing condition was rating as a bit easier than the speech condition, especially in the creation of content, which is also due to what I said just before, that participant had to sometimes repeat the inputting of data a few times. Then last, user experience. User experience has usually 2 dimensions. You have the pragmatic dimension, which refers to the possibility of effectively and efficiently achieving goals. And then the hedonic dimension, which refers to the stimulating properties of the prototype. And here there were clear tendency where typing was rated as more pragmatic, and this confirms what we have already observed in the previous slide. And speech was rated as more hedonic and more stimulated than for the task. What do we conclude from that? So first of all, we can say that one of the contributions is that we have shown that producing interoperable annotation of visualization is feasible based on the schema.org mappings and the data model that we have proposed. And now to produce these interoperable annotations, I think we see that speech is promising. So looking into ways of incorporating these in metadata production workflow could be a fruitful research directions, especially for thematic maps, as we have studied them here, and historical maps, which are mostly static. And we have both interactive maps and static maps during the study. Now, more generally, I think how to combine the two interaction modalities so that we can increase user experience and we can increase efficiency, effectiveness is the question, and that is a question that is relevant to more than an area in geoscience, for example, spatial data infrastructure, sensor web, reproducible research, or a digital earth vision are all sub-area of geoscience that would benefit from from way of supporting participant in producing metadata in an enjoyable way. What next? We have few questions, but this one is the one we will pick. In fact, it has come clear during the work that summarizing the graphical annotation is a bit of a challenging task for two reasons. The first reason is that the reference systems are related to the screens of the participant. And that's why you have, for example, this annotation here, which is offset because the mapping of the reference system is not accurate. So this is something to look into in future work. And the second thing is how do you combine all these geometries to produce one or several, which quickly give an impression of the intensity of the contributions of participant when it comes to the patterns in the visualization. So to close, we have proposed a data model, which is based on schema.org for interoperable annotation of web maps. We use this data model as basis for the prototype that we have developed. Then we had a study investigating typing and speech, their merits. They both were comparable as far as input duration time is concerned. But typing has, speech has hedonic properties that when integrated could probably increase user experience of during web metadata creation. Acknowledgement of the icons that I have used, and thanks for attention, and we are looking forward to your feedback.